Hello everyone. So I was learning Fast API and a hackathon was coming up, so I thought I will make a project for it. This is a financial guidance app and I will tell you what happens under the hood. How a Fast API backend, React Native frontend, Firebase database, and an OpenAI talk to each other. But at first, let us go through the features very quickly. In the dashboard, we have expense progress, savings progress, and this cool AI feature, which I will talk about in a bit. In the expenses tab, we can pick an expense and add it. It will be shown in the recent transactions, and it will be updated in this dashboard as well. In the goals tab, we can create a goal and keep depositing in it. It will be updated here too. In the budget tab, we can allocate budgets for all those categories. We can also reset everything using this button. We can also set our monthly income. Then we have this learning tab where there are several courses based on finances. A user can pick a course, open a lecture, mark it as completed, and then take a quiz. Let me complete this quickly. The user will be granted some points based on the score of the quiz. Then let's talk about the AI. The AI will give suggestions and predictions based on the user's spending habits. It also considers other factors like the expense progress and the amount of money that he wants to save. We can generate more suggestions using this button. There is also this AI chatbot where a user can ask any financial queries. We also have a translator here from English to Bangla. So that's about all the features. Now let's talk about the Fast API backend. The app never talks to the Firebase directly, and it never holds any API or secret keys. Everything goes through the backend, and I will show you how. When the server boots, this lifespan function right here runs first and calls this init Firebase function so that we can connect to the database once at startup and fail fast if the credentials are missing. Then we create the Fast API app at course, so the mobile app is allowed to call us, and we mount the three routers, which are auth, data, and AI. Auth is basically for authentication, login, registration, and data is for the user data, and this AI is for the basically the AI feature. Then we also have this health endpoint just to check if the server is alive. All the configuration lives here in this config.py file using Pydantic settings. The key idea is every secret, the JWT secret, the Firebase key path, the OpenAI key is read from environment variables or .env file that is never committed. So there are no secrets in the code. Now let's talk about the database layer in this firebase.py file. We use the Firebase admin SDK, which authenticates with a service account key. Two things to notice here. First, this init Firebase is idempotent. The initialized flag right here means even if it is called twice, it only connects once. Secondly, this ref helper is the only way the rest of the code touches the database. Let's say you give it a path like users slash some ID and it hands back a database reference. Because we go through the admin SDK on the server, the app never needs Firebase rules or Firebase credentials on the device. Now let us take a look at the security.py file. Two things are done here: password hashing and JWT tokens. The password hashing is done with bcrypt. We never store a raw password, only a hash. There's even a small detail where we clip the password to 72 bytes because that's the bcrypt's limit. Then let's talk about the JWT tokens. Here, the create token builds a signed token that carries the user's ID, email, and expiry. The decode token then verifies it. This is what keeps the user logged in without us storing sessions. Now let's check the schemas.py. These are the request and response pydantic models. So when someone registers, the email has to be valid, the password has to be at least 6 characters, and the fast API rejects bad input automatically before our code even runs. Now let's understand how registration and login works. Let's go to the auth.py file. Uh, let's understand registration first. At first, we take the email and normalize it. We check an email index in the database. That's a little lookup table mapping email to user ID, so we can tell instantly if the account already exists. If it does, we return a 409 conflict. Otherwise, we generate a user ID and then we hash the password and then write the user record into user/UID. Then we save the email to ID mapping, and finally we create a JWT token and hand it back with the user info. Now let's understand how the login works. We look up the ID by the email and then we fetch the users and verify against the hashed password. And if it matches, we then issue a token right here. Also, this current user is literally the gatekeeper. It reads the authentication bearer, then decodes the JWT, and then loads the user. Every protected endpoint depends on this. If the token is missing or expired, you get a 401 error. This one function is what secures the entire rest of the API. Now let's take a look at the data.py file. In the overview endpoint, you can see that instead of making the app call 5 different endpoints, one call returns everything. We need things like budget, categories, expenses, goals, arcade. So after hitting this API, we get all the information at once. Also notice this, that we do not store how much was spent in a category. We always derive spending by adding up the actual expenses. That means that expenses are the single source of truth. Deleting an expense and the money will automatically be freed back into the budget. That means that no data can ever get out of sync. The rest are the actions basically. Hold on a minute. Here you can say add expense, delete expense, add goals, update goal, and deposit towards a goal. Notice one thing, that we are clamping the saved amount, which means that it cannot exceed the target amount of a goal. Another thing to notice is that each of these endpoints depends on the current user. That means we can only manipulate our own data. Lastly, the arcade/complete endpoint. Here, uh, awards are offered the first time a quiz is completed, so that a user cannot farm points by repeating the quiz many times. Another thing to notice is that uh, at the top, some defaults are set for all the values. When a new user shows up, the seed if empty plans a starter budget with Bangladesh specific categories like food, transport, etc., and a few sample saving goals like Eid, emergency fund, Eid shopping, and emergency fund, etc. So the app is never empty on day one. Now let's talk about the AI.py router. Here we have two models to validate the input. turn for a single message, and chat in for the whole request, where we have system prompt, the chat history, and temperature and total limits, which are capped so nobody can send bad values. Then we have the chat endpoint. It works only for the current users, current or logged in users. Uh, if there is no API key, it stops right away with 503. Then the message list is built starting with the system prompt and converts our model role into OpenAI's assistant role, since the two use different names. After making the payload, everything is sent to OpenAI with the API key and a 30-second timeout. If the service can be reached, it returns 502. If OpenAI returns an error, it passes that message straight back. And finally, it pulls the AI's reply out of the response, trims it, guards against empty text, and returns a clean format. And that's how it establishes a secure and validated bridge between the app TakaTrack and OpenAI. The app is available on GitHub, and I have uploaded the backend on Render. I will provide a Google Drive link of the APK as well. You can try the app if you want. Thank you very much.